In this module, Energy Monitoring System Overview, we look at the investigation, design and implementation of an energy monitoring system within an energy review. To be as realistic as possible, the module uses an actual factory case study. It illustrates the process of how the first phase of an energy monitoring system can be defined. There are 5 important procedural steps. First, agreement with top management on the expected payback period of a first phase energy monitoring system. Getting initial commitment from the system owner is a vital step. Second, based on how the energy account centres are organised, minimum required metering points should be assigned, taking into account how people will handle the accumulated data. Third, the system structure should be defined. And fourth, man-machine interfaces for information sharing purposes need to be defined. And finally, the total cost within an agreed budget, which should fall within a 1-year payback period, needs to be agreed. To help you understand the scale of the monitoring system in this case study, here's some background information. The company has annual revenues of $130.9 million and consumed 21,360 gigajoules of energy in 2010. Energy costs were $2.78 million in 2010, and the company employed 423 people and operated a 2-shift production site between 7 in the morning and midnight. To conduct an effective energy monitoring investigation, you must have a clear vision of the expected savings from the system. That helps to determine the appropriate size for the system. In this case, the identified target saving was 4.9%, valued at $136,000. The energy manager asked the energy management system owner what an acceptable payback period for the system was. The answer came back 1 year. That gave the energy manager an immediate budget maximum of $136 for the monitoring system. An important tip for monitoring systems is not to go for the perfect system that gives you an overview of everything from the start. In a table of energy conservation opportunities, recommendations for monitoring systems that will feed into the coming planning cycle should always be at the top. They demonstrate the importance of energy monitoring in an energy management system. And here are the parameters for investment in energy monitoring in this case study. The recommendations were payback period 1 year or less, derived saving target from operations 8% for electricity, that's 680,000 kilowatt hours or $86,000, and 3% for heating oil, equivalent to 102,000 litres or $50,000. The saving target was $136,000 in total. The time for payback was 1 year. The investment $136,000 or less, and the recommendation for the first phase monitoring system was a total cost of $118,000 or less. And here's how to determine practical metering points without seeking perfection from the start. Don't look for detailed monitoring in the first phase. Start with group monitoring, and once that is running smoothly, gradually introduce the monitoring points. Prioritize monitoring needs from a significant energy use perspective. In the case study, they identified 10 energy account centres as user monitoring points. Identify the output denominators needed to derive energy performance indicators. Define the guidelines for improvement actions that will come out of the monitoring procedures. The table on the right gives a description of the energy measuring point assigned to each energy account centre in the case study. In the case study, points for 44 energy monitoring meters were identified, given the cost constraints of $118,000. And here is a scheme showing the configuration of monitoring points. At least one monitoring point per energy account centre was a requirement. And here's a first phase of the energy management monitoring and action system configuration. An improvement action procedure associated with the monitoring system was a high priority. Otherwise, the monitoring system will only be used by a select group of people without serving its real purpose. The overall procedure was to obtain energy and performance-related output data on a daily basis to derive energy performance indicators that are based on specific energy consumption. The performance indicators should be presented to the daily meeting and energy performance evaluated by comparing the energy performance indicators to the baseline energy performance indicators. Based on that performance review, daily actions for continual performance improvement should be set. The energy performance indicators should be fully analysed by the Energy Management System Operations Committee, and continual improvement actions should be identified and presented at management review. This is the table of the monitoring system estimate from the case study. And this is a table of savings targets assigned for each energy account centre after the installation of a monitoring system with improvement procedures.